Hi, my name is Toni Perämäki. I'm the Chief Operating Officer of Valohai. Valohai is a deep learning management platform, and we help companies and data scientists who are building custom deep learning and machine learning models to build, train, optimize, and deploy the models in production at least 10 times faster they are doing it today. What I'm going to show you next is the combined solution of Valohai and SwiftStack. So SwiftStack is the leading multi-cloud data management platform, providing enterprises universal access to cloud-native storage for unstructured data in a single namespace. And it also extends the workflows across private and public infrastructure. In our partnership, Valohai and SwiftStack are combining our services to bring you the world's first petascale machine learning solution that covers everything from data management to computation and full version control of the models and model pipelines. So let's jump to the demo. What I'm going to show you is how to train and deploy a deep learning model by leveraging Valohai, and as the data management layer, we're going to use SwiftStack. And what we're going to do is a couple of things. First of all, we're going to do batch feature extraction step, so a small data transformation for our dataset. After that, we're going to go to model training and train our deep learning model. We're going to jump on hyperparameter optimization by leveraging multiple GPU machines in parallel. And in the end, we're going to deploy the best performing model to a live Kubernetes endpoint for validation. Before we get started, let's go through the basics. First of all, Valohai is fully built on APIs, which means that we have three ways of interacting with the platform. First, we have the CLI, so command line client, and this is what most of the customers and our data scientists are using when they're working with their models. So they are usually working with their favorite IDEs and then using the command line client to launch different machine learning workloads into cloud. Then we have the graphical user interface, which I'm going to show you in a couple of minutes. And it comes handy in situations where let's say you're doing hyperparameter optimization with 50 machines in cloud in parallel. So giving a more visual view on how your models are converging and how the trainings are going on helps a lot. And thirdly, as we're fully built on APIs, so every feature that Valohai has can also be invoked through the API. So let's start with a demo. Valohai interacts with your code by leveraging GitHub or Git or Bitbucket. So let's jump to the repository. So what we have here is a Tensorflow example on the MNIST dataset, as we discussed earlier on, and we have here a couple of things in the repository. First of all, we have the batch feature extraction.py, which is the first step of the pipeline, and it does a small data transformation. Second of all, we have the train.py, which is the training code for the actual model. So we have a two-step pipeline. But leveraging different files, you can create as complex and long pipelines as you want. And how you tie all this to Valohai is basically through one simple configuration file called Valohai YAML. So let's look into that. So what we have in Valohai YAML file is a couple of things. First of all, we got different steps. So here we have batch feature extraction step, and then below it we have the model training step. And what's inside steps are a couple of things. Every time you run something on Valohai, we tie your code to a specific software environment, so a Docker image. This way, you can make sure that if you have a model, for example, which you've trained 6 months ago, and you want to retrain it with a new dataset or evolve it further, you don't have to start from thinking about what version of TensorFlow did we have 6 months ago, or what version of Python we used 6 months ago, but your code is always tied to a working environment. Then we have the actual Python command, and then we take in the parameters. So here epochs, learning rate, and dropout. And we give some defaults for them, but that's not mandatory. And lastly, we define the input, so where your data lays. So in this case, we're using SwiftStack, but it could be Azure Blob Storage, Google Cloud Storage, AWS S3, or OpenStack Swift. We can also take a look into the SwiftStack data storage. So here we have the SwiftStack client where we have already earlier on set up our account. And as you can see, when we jump in the data section, we have our bucket here. And inside the bucket, we have the training data set that we're going to use for the actual model training. So let's jump back to Valohai. Tying your code to Valohai is as simple as copying the URL, jumping to valohai.com, logging in. What we get first is a project view. So we have different type of projects that we've been creating earlier on. So let's create first a new project. Valohai demo proj. Then we put the ownership to us ourselves and create project. First we need to jump to settings, repository, and paste the URL we copied earlier on here. If you are using a private repo, then here you basically add your SSH key, but as our repo is public, we don't need to use that. So we just save, and what Valohai does is fetches the latest commit. And before we jump to the actual executions, we'll have to configure the data storage. So let's jump to settings, data stores, and select OpenStack Swift Object Store. And next we'll have to fill in these. And then we're ready to create. So now we have defined the data store. So now we're ready to create the first execution. What we have here is the basic execution window of Valohai. Most of the information is pulled dynamically from the YAML file, but there are a couple of things that we want to look into. First of all, we have the environment part. So basically here you can see the full lineup from all the cloud players, from AWS to Azure to Google Cloud, or if you're using your on-prem hardware, your cluster will be visible here. So let's now pick the G2 large for this execution. Then you have the code version, and then we have the steps, which are basically the steps that we defined in the YAML file. So let's start with the feature extraction. Everything else can be left the same, and then we just create execution when we want to run. And what happens next is that Valohai basically spins up the machine, pushes your Docker container, uploads your dataset and your code, and then starts running the execution that was selected. If you've been using GPU machines earlier, you know that spin up time is not the couple of seconds that we have here, but it actually takes over 10 minutes just to spin up a GPU machine. So why we're able to do this fast is basically because we keep machines preheated to our customers. We do a lot of caching, so caching the most used Docker containers next to the machines, and obviously pushing our code to machines that have already the right Docker container. And then after the execution is done, whatever is the output is then taken and pushed back into your data storage Swift container in SwiftStack. Every time you run something with Valohai, Valohai automatically saves the versioning information. So for example, here we can see that this execution was run on G2 large with a specific code version. This was the feature extraction step by using specific Docker image. And then we have the inputs and also when it was created, by whom, how long the execution was, and what was the price of it. And then you can use different tags if you want to find this specific execution through tagging. On the output folders, we can now see the feature extraction version of the data. So now we've done with the feature extraction. So next step is obviously doing the model training. So let's create the second execution. So we can leave most of the stuff the same, but what we want to make sure that we switch the step. And now, as we already did the feature extraction, we don't want to use the original input files, but actually the output of execution number 1. So let's switch those files. So as we know the file name, Valohai can right away, after writing a couple of first letters of the file name, find that there's an output of execution number 1 that we uploaded 4 minutes ago. So take the training images, and then we take the training labels, and then switch the test images and test labels. And last section here is the parameters. So we have the defaults that were pulled from the YAML file, but we can change these as we wish. And when we're ready, we can just create an execution. And now, whatever you want to follow, you can print into standard out in a JSON format. And what Valohai does is that we automatically pick that up for you. So this way you can basically see how your models are converging, and if there's a need to stop the run, you can just stop it, copy it to a new experiment, change the dataset, change the code or something. So you don't have to wait till the end of the run before you can actually get some results and understanding. Then obviously the logs are again automatically saved, and now we also have the parameters here. And then in the output folders, we can see that we have both the layers and their weights and biases. And what Valohai actually automatically did also was created the model.pp, which is the serialized version of the TensorFlow model. So what we noticed that data scientists rarely pay attention to the optimization of the hardware environment. So basically what Valohai does is that we show you in real time the hardware stats, and then also say the peak memory and peak GPU usage. And we also log them over time, so if you want to dig deeper, that's possible. Let's look back to the SwiftStack client. Since we've already done the feature extraction and the model training, we can see that here in the data storage, we have automatically created a folder for data. And if you look into it, we can see that we've automatically saved the outputs for both of the experiments that we've done. So let's look into it. So here we basically have the weights and biases for both of the layers, and then the actual serialized version of the TensorFlow model. Good. So let's jump back in Valohai. So now we've done the feature extraction and the model training, and seems that our model looks pretty good, but obviously we want to do some hyperparameter optimization to make it even better. So that is tasks in Valohai. So what we do is create a task, make sure it's the model training. So task is basically pretty much the same step that we had in the training, but now instead of taking in single parameters, we can take in multiple parameters for each of the. We could use linear spaces, logarithmic space, or pure random search. And as Valohai is fully built on APIs, if you're using your own more advanced or intelligent optimizers, say you might be using SigOpt for hyperparameter tuning, you can use that and plug it in with the APIs. But now, for the sake of experiment, let's just create a simple grid search. So now we have a total of 27 executions. And when we want to run all of these, we just create the task. And now, instead of running just one experiment, Valohai takes all the 27 executions and runs them in parallel. Our demo account has maximum 10 instances in parallel limit, but we have customers that are doing 50 to 100 GPU machines in parallel when they're doing hyperparameter optimization. Then, on the metadata layer, we can see in real time again how the models are converging, and we can adjust the scale so we can see more thoroughly on what we want to follow. And in addition to the visual view, we have also list execution window. So here we are basically able to follow all the different aspects of the execution in a list view. So you can basically see that if a specific parameter space is working better than others and so forth. So let's list these in the accuracy. So currently the best functioning model is the number 6. Let's look into that. And if we jump to the metadata layer, we can see that, okay, it looks pretty okay. So let's assume this would be the model that you'd like to take into production. Normal procedure would be that at this point, you would take the weights and biases of the layer and the model itself and take it to your engineering. And depending on how busy they are, setting up the model somewhere up and running takes 2 hours, 2 days, or 2 weeks. What we've been wanting with Valohai is to help data scientists to own their models and the whole pipeline. So what we've done is created a deployment model that the data scientists can use and deploy their own models for validation or to attach to production immediately after the training. So let's look into that one. Only thing that you need to know at this stage to take this model to deployment is the number of execution, so 6. So we jump to deployment tab, create a deployment, give it a name, and then we set the target. Here we have only default, but basically if you would have different cloud region you want to target, then you would have those here. Click OK, and then we create a version. So we have a testing environment and then the actual serving environment. And as said, only thing that you need to know is the execution number. And then we pick up the serialized version of the TensorFlow model, which we created as we trained the model, and create a deployment. So now what Valohai does is that we set up a scalable Kubernetes cluster and host your model on that. So basically in 2 minutes you can take this URL and start shooting, in this case, pictures of numbers to get predictions. We also wanted to help data scientists to get their deployed model attached to a deployment environment, so we created an alias system. So what we can do here is create different aliases. So let's do one for testing, one for staging, and then create one for production. So now we have 3 different alias endpoints. So now when you're doing your deployment and getting the URL, every time you do a new deployment, you don't have to go to the software team or engineering and give them the new URL, but actually you have static production, staging, and test endpoints. And when you develop a new model and deploy it, you just, from Valohai, switch it under the alias system. So that way you can get the new model right away attached to your testing environment. So what we went through here was a simple model training with a feature extraction step, model training, hyperparameter optimization, and in the end we picked up the best performing model and deployed it to a live Kubernetes endpoint. Our most advanced customers, in addition to these type of pipelines, they are also creating automated pipelines. So with Valohai, you can basically do different triggerings. So let's say you have a model running in production, and every time the dataset changes a specific amount, that would trigger a retraining of the whole model pipeline. So take the new data, do the feature extraction step, train the model, and automatically deploy the model to a testing environment for validation. And after the model is validated, you could then switch it to production. Also, what you should know that with Valohai, we don't restrict you into any specific framework or any specific technology. So anything that you can put inside a Docker and run, we can run. So this means that you are not only required to do machine learning workloads on the platform. So we have customers who are doing different data transformation, pre-processing steps before the model training. And we have even customers who are, for example, generating synthetic data with Unity on top of Valohai as the first step of the pipeline, and customers who are after the model training and before the deployment doing some kind of model compression steps and so forth. So this was a short demo on Valohai Deep Learning Platform, and if you're interested in hearing more or learning more, go to valohai.com. There's a lot of information, and also check out our blog. We have a lot of different resources around deep learning in production. And if you're interested in discussing further, feel free to contact me via my email or the phone number visible on the screen. And you can also go and book a demo through our webpage, valohai.com. We're happy to help and accelerate your model development capabilities to the next level in a way that you are compliant with the regulatory requirements of today and tomorrow. Thank you.